Find the 8th term of the expansion of 2x plus 1 over x to the power of 12. Now what we don't want to have to do here is do the full expansion, because there's going to be 13 terms and a lot of work in that. So let's try and reduce what we need to do. But we're still going to use the same structure, the 3 rows. We still know we need Pascal's row, we need increasing powers of A, and decreasing powers of B. So let's think about how we're going to do this. Well, there's a bunch of terms. In fact, there are going to be 7 terms, and then we're going to get to the term we want. And we know that that term is going to be 12 choose. It's 12 because we're in the 12th row of Pascal's triangle. And it's going to be 12 choose 7. And the reason it's going to be 12 choose 7 is because we start counting at 0. Remember, the first one in Pascal's triangle was 12 choose 0 up to 12 choose 7. And then there's going to be a few more terms going on. So the first thing we're doing is finding the Pascal's row. Now the second part is our decreasing powers of A, which in this case is 2x. And then we're going to have our increasing powers of B, which in this case is 1 over x. Now because 1 over x is increasing, it's going to have the power is going to be the same as the value we're in Pascal's triangle. And that's always true. Okay, this is always going to be equal to the r in n choose r. But the other thing we know is that these two powers always sum up to 12, the total power. So once we know that one's 7, we know this one has to be 5. Now with a bit of simplification, we can work out what this is actually going to be. 12 choose 7. We can type that into our calculator and get 792. 2x to the power of 5 is 32x to the power of 5. 1 over x to the power of 7 is going to be 1 over x to the power of 7. So the 8th term is going to be equal to whatever 792 times 32x to the 5 times 1 over x to the 7 is. Well, 792 times 32 gives us 25,344. And the x to the 5 over the x to the 7 is going to cancel down to over x squared. So this is how we can still use that same structure to answer questions like this. And actually, any of these questions that we encounter, we can do that. All that's going to change is the order that we fill in those different elements. So the elements that we're going to need to fill in are these 3. And depending on the type of question, we're going to fill them in a different order. In this case, we filled them in. This one was number 1 because we knew we were at number 7. This one was number 2 because this power always equals this value here. And this one was number 3 because we knew the 7 add this power had to be equal to 5. But these are going to change. The order we do these are going to change depending on what the question is asking.